lesson, we're done with cells, and we're done with 2015, which is the year that I recorded the part of this lesson that you've watched so far. And we're done with that old 2015 microphone. I guess I need to explain all this. I've traveled forward in time again, and I'm now speaking to you from July of 2018 with a brand new microphone that makes me sound even better, if you can imagine that. If you watched the videos in the first lesson, which were added in March 2018, then you've already heard this more mature mic as recorded by this less mature mic. Get it? I'm a mic, and my microphone is also a mic. And see, I'm older and it's younger. Man, I just crack myself up sometimes. My goodness. Anyway, in that segment, we showed you the MATLAB desktops for both MATLAB Online and Install MATLAB. MATLAB Online hadn't even been invented yet back in 2015, so I had to jump forward in time in order to be able to use it. And now I've gone back to the future again so I can tell you about some new data types introduced by MATLAB relatively recently. No matter when you're watching me, this course has already covered all the data types that have been part of MATLAB since back in the 90s. You know, the double and single floating point numbers, all the integer types like int 8, unsigned, int 16, etc., and the char and the logical and the struct and the cell, which we just now finished with. By just now, I mean in the segment you just watched, which was recorded 3 years ago. But in the next segments, we're going to look at some new data types. If you're using an older installed version of MATLAB, you may not have these types. But if you're using MATLAB Online, then of course you'll definitely have them, because MATLAB Online is always right up to date. And speaking of being up to date, I'm using the very latest version of MATLAB, which today is, as you can see up here, 2018A. And which is exactly the same version that I was using when I introduced the desktops in the first lesson. The A in the name means that it's the first version released in 2018. MathWorks has for many years released 2 versions of MATLAB per year. The first one shows up in March and is labeled with an A. The second one shows up 6 months later in September and is labeled with, you guessed it, a B. The changes are usually not big, so you can stick with one version for a year or 2 or even 3, and you'll still be fine. We'll add one new video segment for each new data type that we think you should learn about. And you can look at the title of each video to see the name of the type and the version of MATLAB in which it was introduced. The segment that we're in now, for example, is entitled The String Type Introduced in 2017A. You may wonder how the string type, which we are introducing now, relates to strings, which is the title of an earlier segment in this lesson. We'll talk about that relationship in great detail in a few minutes, but a quick overview is that both of these types are used to hold words, phrases, sentences, etc. But as we point out in the earlier segment, the type of the strings in that earlier segment was char, not string. There were some problems with using char to hold strings, and MATLAB introduced a new type with the name string to solve them. We just finished using the old string right there near the end of our segment on cells when we formed the word strawberries. Let's get some more strawberries. In this command, we've assigned the string strawberries to the variable named fruit. Let's determine the type and dimensions of fruit by using the class function and then the size function. So the function class tells us that the type of this variable is not string at all. The type is char, which you can see right here. The name string is just an informal way of saying a vector of chars, each of which is printed on the screen as a character. S, T, R, A, W, B, etc. The size function reminds us that this so-called string is a row vector, just like any set of characters that we enclose in single quotes. And this particular one has 12 elements. Hey, look, I know you remember all this char stuff and are probably edging closer and closer toward an epic case of total boredom. But before you drift off to sleep, I just can't help but also point out that when the function class returned the type of fruit right here, it did it with an output argument whose type is also char. We know that because the word char is surrounded by single quotes. Okay, hello! Sorry about that, but you should probably wake back up now because here comes the new string type. To get it, we can simply use double quotes instead of single quotes, like this. So there you go. You are looking at a new string. You can tell it's the new string because it's surrounded by double quotes instead of single quotes, the way the old string was. And there's something remarkable about these double quotes. Other languages like C, C++, and Java have used double quotes to denote a string for decades. But double quotes had to wait 40 years to be given a place in MATLAB. Congratulations, DQ. You're in the game and you're looking good. Note that our new string type gets the same purplish pink color that we got when we typed in a char. So there we are. We now have our first new string. Or to put it another way, we have our first string. I'm not always going to say new string for two reasons. Number one, you can figure it out from the context whether I'm talking about a string that is a char vector or a new string. And number two, I'm tired of saying new string. If we need to distinguish, I'll call the old version a char vector or a char string or just a char. Otherwise, string means new string. To prove that new fruit is in fact a string instead of a char, let's check it with the class function. Sure enough, it's a string. But the class function still gives its answer in the form of a char vector, no matter what type of input it gets. We'll talk about differences between chars and strings in a minute or two, but first let's talk about a similarity. Probably the most important similarity is that almost any built-in function that's designed to process a char vector will process a string in the same way. The prime example is good old fprintf. As you can see from these two commands, it's happy with a format argument that is either a char vector or a string. And then there are all the built-in functions that were designed originally to manipulate char vectors. They're also happy with the string. Let's put one of those happy little functions right here in the command window. Remember the function that we used earlier in this lesson to search for a substring inside another string? It returns all the starting positions of the substring everywhere it finds it. And the name is string find, abbreviated for the function name as strfind. We'll first make an old char string, and then we'll call string find to find something in it. Let's see. Inane refrain equals the rain in Spain stays mainly in the plain. So we've got the string to search in, and we're going to search for, I don't know, the string in, like this. There, string find happily searched through the string in the first argument, looking for the substring in, which was the second argument. It found it in 6 places and gave us the index for each one of them. Now maybe we want to have another happy little string find function call. And let's do something different with this one. Let's give it a string for the first argument instead of a char vector and use the same second argument. Riddle equals bushy-headed trainer in an art form mainly planar. There. As you can see, our happy little string find function is just as happy with a string as it was with a char. And I could have used a string for the second argument too. By the way, if you need to look for more complex string patterns, like, for example, every substring that starts with a lowercase a followed by one or more lowercase letters followed by one lowercase r, then you should look up regular expressions and the built-in function that searches for them named regexp, which stands for regular expression. It'll take you a while to get used to it, and by a while I mean days. But here's how to tell it to find that substring example. And take my word for it, it found it 3 places. I can show you lots of examples of such string functions that were originally designed for char vectors but also work for strings. But for now, I'll just show you that the function upper works fine with both types, and let it go at that. And of course, the function lower works just as well. So, all the built-in functions have now been tweaked by the MathWorks programmers so that they do their things with either a char or a string. In other words, as we've learned, that means that they're all polymorphic functions. Since char and string are different types, these functions have to do different things internally with them. But that's the beauty of the concept of the polymorphic function. You just give it the argument, and the function looks at the type and figures out what to do. That's the best way to write any function that might be appropriate for use with more than one type, if you have the time. But let's suppose that you've already written a whole bunch of functions that require an old-fashioned char vector instead of a string, and you don't want to, or you don't have time to, change all of them to handle strings too. Well, never fear, the converter is here. Before we find out what that means, let's suppose you've written a function that reverses a row of chars, just like this one over here, called myStr function, which is supposed to mean my string function. Here's what the function looks like. It's just a one-liner. It takes the input, and then it just plays it backwards for you. And let's suppose you want to reverse strawberries. Let's first see what happens when we input strawberries as a row of chars. That's what we assign to the variable fruit, so let's use that as an input. I think I'll clear this cluttered command window first. And let's move this command window underneath the editor so we've got a little bit more space. There we go. Clean slate. All right, now let's try out our function on the char vector strawberries. Well, that looks kind of disgusting for some reason. But the function is obviously working because the variable fruit contained the word strawberries, and C. Arab warts is strawberries spelled backwards. Now let's give it the variable new fruit, which contains the word strawberries as a string instead of a char vector. Didn't do anything. I'll let you figure out why, but I'll give you one hint if you need it. Think about how many elements there are in the input variable new fruit. There's only one. A string, no matter how many characters it contains, is just a single element. So how do we get this function to reverse a string? Well, we can convert the string to a char like this using the function char. Then we can use this char vector as the input, which gives us a char vector as output, and we can convert that output to a string. We need a little more room. Okay, that worked, but it requires 2 new variables and 3 command lines. Well, we can do all this with no new variables and only 1 line, like this. So here we've converted new fruit to a char, and here, after the function has returned its value, we've returned the output of the function to a string. Is that slick or what? We didn't monkey around inside the function itself. Instead, we just switched to char on the way in and switched to string on the way out. I think you've got the picture, but I want to do one more example of converting a char to a string. This example reminds us that in order to insert a single quote into a row of chars, you have to include 2 single quotes back to back. And it reminds me of one of the greatest Broadway musicals of all time, West Side Story. Just thinking of this poignant song gives me goosebumps. I could sing this song for you, and you'd probably get goosebumps too. Well, the kind you get when your skin crawls, but that would be the end of my video career for Vanderbilt, so I'm not going to do that. What I want to point out from this example is that the same sort of doubling requirement shows up for strings. In order to insert a double quote into a string, you have to include 2 double quotes back to back, as in this example. Some people make your skin crawl for a living. Andy Serkis is amazing, but as you can see, I had to put a pair of double quotes around my precious to end up with just single double quotes. By the way, you might have noticed that there's a double comma too, but unlike double quotes, the commas come through doubled in the string itself. That just shows that this double to single business doesn't happen with any other punctuation marks, or any other characters for that matter. Don't I have quite the knack for making simple things sound complicated? Maybe that means I'm a really bad teacher. Or maybe I'm cleverly making it sound like you're learning really hard stuff so you can impress your friends. Of course, it's not really hard at all, but the single versus double quotes business is the most obvious difference between the 2 types. This is a syntactical difference between them, and syntax is usually much easier to understand than semantics, as the semantics of the 1-line string reversing example above shows. There are other semantic differences that we need to look at, of course. One nice difference is that the string type does not suffer from a particularly irritating limitation of the char type, which we ran into in Lesson 7. The limitation occurred when we tried to put more than 1 row of characters in a 2-dimensional array of chars. Before we try that again with the char version of strings, which will fail as miserably now as it did then, let's see how easy it is to do it with the new string type. Here, 3 by 1 string array means that there are 3 rows, 1, 2, 3, with 1 string on each row. Regardless of the number of characters in a string, it's just 1 element. And since there is just 1 element on each row, this is a column vector. Okay, now I'm going to try to make a stack with the char version by using single quotes instead of double. Oops, here's that red stuff. Dimensions of arrays being concatenated are not consistent. We saw this same error earlier in this lesson. The error was worded slightly different in the 2014 B MATLAB that I was using then, but the problem was exactly the same. That problem is that in this second command, this one, we are trying to make an array whose rows do not all have the same width. whereas in the first command, the ace on the first row is just one single element. In the second command, ace comprises the three elements A, C, E. And in the first command, king and queen on the second and third rows are also each just one element, whereas in the second command, king on the second row has 4 elements and queen on the third row has 5. MATLAB never allows different numbers of elements on different rows of the same array, as we first pointed out in Lesson 2. Arrays are rectangles, meaning that all their rows have exactly the same width. And I can guarantee you that until that sad day when MATLAB finally ceases to exist, which by the way is over 200 years from now, it will continue to enforce that rule. What? How do I know it's over 200 years? You've forgotten I got a time machine? I know many things, my friends. And this rule, stretching forth over the centuries as it does, has nothing to do with chars or strings in particular. It's a basic rule of arrays, and all the widely used computer languages enforce this same rule. As we saw back there in Lesson 2, you'll get the same error if you try to sneak around and put different sized rows into an array of doubles instead of chars. Let's see, I don't know, let's just do this. There, the first row has 3 elements, the second row has 4, and the third row has 5. Now let's hit enter. No go. Different type, same rule, same error. If you really need a stack of different length strings of type char, you can use this handy little trick. When you give a column of strings as an input to the function char, it not only changes the type to char, but also adds just exactly the right number of blank characters to the right of each short row to make all the rows the same width as the longest row. As you can see by the space between ace and its closing quote mark, and by the space between king and its closing quote mark. So it returns a rectangular two-dimensional array of type char. All strictly legal. Okay, we put strings on top of one another, but what happens if we put them side by side? Let's clear the command window and do that. And we'll do it with strings first. No surprise there, we put in 3 strings in a row and got out a row of 3 strings, which is, as MATLAB says right here, a 1 by 3 string array. Now let's try the same thing with the char version. So what happened here? Why do all the letters get shoved together into a single string of chars? Well, this same thing happens anytime you put multiple row vectors on the same row. You end up with a single row vector containing the elements of the multiple row vectors, one immediately after the other. It works the same way with numbers, of course. Here's an example of that. When you combine multiple strings together to produce one string, you are concatenating them, which we've talked about before. And after strings are concatenated, you can't tell where one ends and the next one begins. But sometimes concatenating strings is exactly what you need to do. So how can you concatenate strings? Well, you just add them. By add, I mean use the plus sign, which we've used so far only to sum up numbers. Here's how it works with strings. Hey, I wonder what happens if we use a minus sign. Let's try that. Wow, how about that? MATLAB figured out that these strings are numbers, and then, just kidding, I faked this one. Here's what really happened. And you'd get an error like this with any other arithmetic operator too. The plus sign is the only arithmetic operator you can use with strings. Enough with concatenation. Let's clear all that away. And get back to conversions. We've converted between strings and chars, but what about converting between strings and other types? Well, for openers, you can convert any number to a string. First, let's look at 4 examples with numbers of the type double, which is the default number type in MATLAB. And here's a 5th example in which we convert from one of the integer types to a string. This works for all the other number types too. Okay, these examples came at you pretty fast. Let's examine them a little. The 2nd and 4th examples, here and here, show that only 4 digits after the decimal place are given in the string. This is MATLAB's short precision, which is the default in the command window. The 3rd example shows that the string function also uses the default number format of the command window, which is fixed point, instead of floating point, which was the form of the input for this example, as you can see here. The 4th example might seem special because the input was pi, but remember that the input argument pi is a function that returns a double, and like any input argument to any function, it's evaluated before it is passed to the function string. When it was evaluated, it returned a double. So string did what it did for the first 3 examples. It just changed a double into a string. And the string function can even convert from a logical. Look at this. And here's a really nifty example. Oh my, looks like I made a little bit of an error here. But MATLAB is helping me out. Yes, MATLAB, I did mean that. Thank you for adding that parenthesis for me. What a great system these MATLAB programmers have given us. But anyway, why did we get this vector of 4 strings? Well, you may remember that the greater than sign operates element by element, and it returns a row vector of logicals. String was given that row vector as an input, and it converted each element to the appropriate string to produce a row vector of corresponding elements. So, to summarize conversion from logical to string, a true input produces the string true, and a false input produces the string false. Not exactly earth-shaking, but this operator can be quite helpful when you need to produce output in string format, say for printing or for exporting to Excel or any other application that takes strings. You can't go the other way, though. As we learned when we tried to do subtraction on numbers written as strings, MATLAB will never try to determine the meaning of words in strings. But you may be surprised to learn that it will determine the meaning of a numeric string. Here's some examples. By the way, only double is capable of this trick of reading numbers in strings. You can't do this with other number types like int, uint, etc. There are some important differences from what happened when we converted in the other direction. Let's pop that one up again from the command history for comparison. The only difference that you can see here is in the fourth example. When we converted from the string pi to a double up here, we get NaN. But when we converted from the number pi to a string, we got 3.1416. So why did we get NaN instead of 3.1416? Well, NaN means not a number. And this is the function double's way of enforcing MATLAB's rule that it will never try to determine the meaning of a word in strings. When you give it a non-numeric string, it returns NaN every time. There's another difference that you can't see. You may remember that for converting from a double to a string, the format short is used. So here. Well, when we're converting from a string to a double, the format is whatever format that is set in the command window at that time. It's currently set to short. But watch what happens if I change the format to long and repeat this command up here. Let me make this window a little bit bigger so you can see what's going on. So what you want to compare is this command and this identical command. And look at this output. This number, we got 1.1235 because at that point the format in the command window was short. Now we get all these extra decimal places. I'm going to take it back to short because that's the way I like it. Before we continue, we should check to see what happens when we give double the old char type of string instead of the new string. Here's a head-to-head comparison. String first, char second. We've already seen the first one, which works perfectly. What happened in the second command? Yeah, we talked about this earlier, but in case you've forgotten, let me go over it again. The argument to double in the second command is actually a vector that contains two numbers that are codes for the two characters that we call 1 and 7. So with the char argument, double gets a two-element vector of numbers, and it converts each of these numbers individually from char to double. That's quite a different thing from what double does with the new type of string. In that case, the string is treated as a single element, and that single element is translated into the single number 17, right here. We showed you a way earlier in this lesson to convert the entire char vector into a number with the function string to num, which is abbreviated str2num. It converts the char vector properly into a scalar double. But I want to show you a new function for doing that called string to double. It's abbreviated str, I'll just type it. There. String to double has the advantage that it also works with a string input. You can't do that with string to num. This function gives you a way to write code that includes a string to double conversion when you don't know whether you're going to get a char type or a string, like this. There. If rand_n returns a random number greater than 0, then unknown will be a char vector. Otherwise, unknown will be a string. And we don't know which one it is. But we don't care because string to double works with either one of them just fine. So that's great, but I have trouble remembering the names of all these functions. Is it string to num or string to double or string to number, or I can't remember all that. So if you're like me, you just do this. There. String converts unknown to a string if it happens to be a char. and then we're handing double a string and everything's fine. Of course, we're making MATLAB run two functions instead of just one, so we might be making it a little hard on MATLAB, but that's a lot easier on us, and that's as it should be. We are, after all, the masters, and MATLAB is our obedient slave. Sometimes, though, MATLAB is not so obedient, like when I ask it to convert a string to an integer type, which, as I already warned you, doesn't work. Conversion to int8 from string is not possible. To that I say poppycock, balderdash, and pish posh. If you're watching this sometime in the future with a MATLAB release that's later than 2018A, and you might not get this error because this conversion is definitely possible, and all the red print in the world won't convince me otherwise because I can prove it. My proof goes like this. MATLAB can convert from a string to a double, and MATLAB can also convert from a double to an int8. So invoking the principle of transitivity, we know that it can convert from a string to an int8. In fact, we can do it indirectly in one line like this. End of proof. QED. Case closed. And more importantly, I managed to work in the word transitivity, which also shows how smart I am. So that's it for conversions involving strings. No, wait, there's one more thing. Look at this conversion. Here we've given the string function a cell vector containing a double, a logical, and a char vector, and it converts each one of them and returns them in a vector of strings. This example shows that the string function will reach inside a cell array and convert different types into strings. This feature lets you avoid having to use looping when you're given lots of heterogeneous data in a cell array, and you need to translate it into strings. So that's it for conversions involving strings, and this time I mean it. So what's next? Well, so far we've treated our new strings as indivisible elements, but they of course comprise a sequence of individual characters. So what if we need to access those individual characters? We learned earlier in this lesson that with the old char strings, we could use normal vector indexing. First, let me clear this command window. Remember this example? That was Plan B for the title of our textbook. So here we've asked for elements 1 through 6 of this string, and that gave us MATLAB. When we first did this, it seemed a little surprising that it even worked, because MATLAB, for smarties, doesn't look at all like any vector we were used to. Well, now you may be comfortable thinking of a string as a vector, but don't get too comfy with this idea because it doesn't work with the new string. It doesn't work because a new string is just one monolithic element, and you can't index into an element to isolate individual characters any more than you can index into a double to get an individual digit. I mean, like this, for example. This isn't going to give us the 7. There's only one element. We asked for element 2, so index exceeds array bounds makes sense, just as it did when we had a string with just one element. But you can do it another way with strings. Here's an example showing you how using a new function called extract between. As you can see, I've given this function 3 arguments. The string that I want to access, the starting position of the characters that I want, and the ending position. Note that the B in the name of this function has to be uppercase. And also note that the word between is not quite right because in addition to the characters between 3 and 8, which is this first D and this D, it includes those two characters too. So it's not really between. I have trouble remembering the name of this function, the capital B, and the meaning of between. Oh my goodness, this is all way too complicated for old Mikey boy here. Fortunately, there's a workaround. Just convert to a char, and use normal indexing, and convert right back to a string again. Sure, it takes 2 steps, but you don't have to remember the name of a new function or how it works. Yeah, I'm sure some people at the MathWorks think I'm wrong to teach this method, but I love it. And if loving it is wrong, I don't want to be right. Here's another example. This stuff is tasty. And now to access some characters inside it. Oops, I guess I should have left the semicolon off. But when you do it, you can leave it off and see the answer to the riddle I gave you 30 minutes ago. Wait, you are doing everything I'm doing, right? Don't be that guy standing over at the side in the yoga class. Okay, I like converting to a char vector and indexing better than using extract between. But the function extract between does other things too, such as extract the part of a string that comes between 2 substrings inside it, as in this example. This works pretty well, and this time the word between in the name of the function is correct. So I'll be the first to admit that extract between does have its place, and so do its sister functions, extract before and extract after. Yeah, there are 3 extract functions. There are a couple of insert functions too, and by now I'm sure you are guessing that there are lots more built-in functions for working with strings and or char vectors. Yep, you're right, 58 of them. 58 functions that MathWorks considers to be the basic functions for working with this data type. And we better get busy because we need to go over every single one of them in detail. So get comfortable because, just kidding, that is not happening in my class. Instead, I'll show you where you can find a list of these functions with links to explanations for every one of them. You can figure them out yourself. I know this because you've made it to lesson 7. I can see also that you happen to be, let me check here. Yeah, you're in the top 5% of the students taking this course. So for you, this should be a walk in the park. Okay, time to clear the command window again. And then I'm going to type doc. And up pops this help window with a document page open that's called MATLAB documentation. To find those links to all 58 string and char functions, here's what you can do. Click on MATLAB, which opens a document page called MATLAB. Click on Language Fundamentals, and just to show you that I can, I'll click on this link on the left over here. These are just links, without all the explanatory text. Both sets of links, the ones on the left and the ones on the right, take you to the same places. And there we go. That closes the MATLAB page and opens up the Language Fundamentals page. Click Data Types, and now we're looking at the Data Types page. Finally, click Characters and Strings. Okay, here it is at last, the list we were looking for. The list of built-in functions for working with characters and strings. Wait, you know what? Before I get into the functions for characters and strings, I want to show you that there are other lists of built-in functions that you might want to consult from time to time. For example, let's go back to the previous page by clicking this left arrow up here at the upper left. And that takes us back to the list we were looking at before. And then let's click, let's click numeric types. And here's a list of functions that work with numeric types. You can scroll down and see all of them. These are functions that are deemed to be basic numeric functions in MATLAB. So the list leaves out square root, for example, and cosine, and hundreds of other built-in functions that also work with numeric types, but aren't considered to be basic. Okay, let's go back to characters and strings by clicking the left arrow, and then clicking characters and strings, and here we are again. The functions in this particular list are hidden from view right now. All you can see are subcategories. That's nice and organized, but if you want to see a list of all the character and string functions at once, just click this teeny tiny expand all over here at the right side, and there they all are. And we can scroll down. And here's extract between, which we've just introduced. I'll click on that, and up pops the help page for that function. Now you can see all the ways that you can use extract between. And this is exactly the same help page that you'd get if you typed doc extract between in the command window. So, sorry, what? Why'd I do it that long way? What do you mean by long? A long way. Oh, I see. Got it. Why did I go through all those other doc pages when I could have gotten here in one command? Now see, just asking me that question proves that you're in the top 5%. The greatest contributions to human thought are questions, not answers. Answers are literally in second place. And here's the answer to your excellent question. It's the only way to find what you can do when you can't remember the name of the function that does it, or have never even heard of the function. What we've just shown you about navigating these documentation tabs will get you to any basic function in MATLAB for any data type. Okay, let's tidy up, because we are done with our introduction to the new string type. And we need to get ready for another new type.